Hi, I'm Jack Bradford. I'm a member of the Pincer Lab here at Texas A&M. Today, we're at the soft matter facility doing pendant drop tensiometry. Pendant drop tensiometry is a technique for measuring the interfacial tension in liquid-liquid and liquid-air systems. Follow me. This is a goniometer. We'll use this instrument to take zoomed-in images of a droplet suspended from a needle in another fluid phase. The primary features of the goniometer are its zoomed-in camera, position-adjustable stage, light source, and dispensing system. Pendant drop tensiometry requires a number of accessories, including a gas-tight glass syringe, an inverted pendant drop needle, which has a blunt tip and wide diameter for droplet stability, a disposable syringe, a standard pendant drop needle with a similar blunt tip and wide diameter, a glass cell for holding your continuous phase, and a hydrophobization kit. Now that you've been introduced to the goniometer and its accessories, let's take a look at what it's doing. This is a schematic of a goniometer, which is really just a camera and a light source. The pendant drop is the liquid droplet suspended from the needle. And for pendant drop tensiometry, the camera records a high definition silhouette of the droplet shape called the droplet profile. The droplet profile is bound by the drop phase and continuous phase at the interface. Different liquid-liquid systems form unique droplet profiles since interfacial tension and gravitational forces compete at the interface. That competition of forces is what forms the very classic-looking drop shape, the pendant drop. We can find the interfacial tension of a liquid-liquid or liquid-air interface using the geometric parameters obtained from the droplet profile. We'll then plug those parameters into the Young-Laplace equation, which relates the interfacial tension to the curvature and change in density across the droplet interface. First, find which syringe and needle you'll need for your measurement. If the droplet is denser than your continuous phase, you'll need a straight pendant drop needle, since the droplet will sink. If the droplet is less dense than your continuous phase and will float, you will need an inverted pendant drop needle. Today, we will measure toluene dropped in water, so we will need to use an inverted pendant drop needle with the glass airtight syringe. Next, you will fill your syringe and needle with your droplet phase. Afterwards, we'll head over to the goniometer and attach the filled syringe to the dispensing system. After loading your filled syringe into the dispensing unit of the goniometer, lower the electronic plunger until it just barely touches the top of the syringe plunger. After loading the syringe into the dispensing unit, bring your needle into the frame of the camera. Focus the needle using the lighting settings and camera settings. Great. Next, you want to place the glass cell, which will hold the continuous phase, onto the adjustable stage and raise it that the needle is surrounded by the cell. Great. Now, fill the glass cell with your continuous phase. In our case, we're filling it with deionized water. After bringing your needle tip into focus on the screen, dispense a droplet of toluene or any given droplet phase and remove any air bubbles. The droplet phase should fill about a third of the screen, but The larger your droplet and the greater the magnification factor of your camera is, the more accurate your interfacial tension measurement will be. Now, to calculate the interfacial tension, we use the Laplace-Young equation, which traces the outline of the silhouette between the droplet and the continuous phase and outputs your interfacial tension. After taking your measurement, dispose of your continuous phase, remove the needle and syringe and dispose of any residual fluid. Afterwards, clean your syringe and glass cell with acetone and let them air dry. Power down the instrument and disconnect the camera from the computer, and you're finished. Thanks for learning pendant drop tensiometry with us today. Remember to consult your standard operating procedure for your particular instrument, as protocols may vary. Thanks and giggle.